In this example, the reactions VA, VB and HB should be determined. I started to demand that the sum of the horizontal forces has to be 0. That means, and I look positively to right, so HB as it's drawn here is negative, it's minus HB, and the 6 kilonewton is positively, it's pointing to right, so that is plus 6 kilonewton. That has to be 0. In that case I could just use the normal solve, so I open this symbolic and take solve. There's only one unknown, so it's no problem. So we can see that HB is 6 kilonewton. So you could give that as a final result for this part. So HB is 6 kilonewton. And it came out positively. That means that we have drawn the direction correct of that reaction. Then I go to find VA and VB. There I had the demand that sum of the moment, I look positively clockwise, has to be 0. That means if I go for point A, that means that this is positive plus the 6 kilonewton multiplied with the arm length 2.5 meter, and VB is negatively, it's counterwise, so that is minus VB multiplied with arm length 4 meter. All that has to be 0, and I use in this case the solve function. There's only one unknown, and I found that VB is 3.75 kilonewton. Then my next demand is that the sum of the moment in point B has to be 0. So I go to point B, and then VA is positive, and 6 kilonewton is also positive. It rotates clockwise. So I said 6 kilonewton multiplied with arm length 2.5 meter plus VA multiplied with 4 meter. All that has to be 0. And then I use solve again and find out that VA is minus 3.75 kilonewton. So this is my result. But then I had to control the sum of the vertical forces has to be 0. Sum of the vertical has to be 0. Means that VA plus VB has to be 0. So I said minus 3.75 kilonewton minus 3.75 kilonewton. And I find out directly equal to, and that is 0 kilonewton. So that must be okay. So in this case I have found out the reaction HB 6 kilonewton, VB as 3.75 kilonewton, and finally VA as minus 3.75 kilonewton.